Hi, today's topic is an introduction to radicals. Now you may be asking yourself, why do I need to learn about radicals? Well, we need an inverse operation to help solve equations involving exponents. From geometry, I got three examples up here of formulas that involve exponents. The Pythagorean theorem, the volume of a cube, and the area of a circle. Note all of them have exponents in the equations. Now you may be sitting there going, okay, so they got exponents in them, but why do I need an inverse operation? Let's look at an example involving multiplication. We know that 4 times 7 is 28. We know the inverse operation for multiplication is division. So that means if we take 28 and divide by either 4 or 7, we're going to get the other number. The division undoes the multiplication. You may be sitting there going, so? Well, let's look at this one-step algebra equation. Here we have 13 times x equals 78. If we want to find out what the x is, we're going to do the inverse operation. So if it's 13 times x, we're multiplying. So if we do the inverse, which is divide, we will get 13 over 13, which simplifies to be 1. 1 times the x will be x. And then if we do 78 divided by 13, we'll get 6. And we figure out that 13 times 6 will be 78. We solve our equation. So having inverses is quite handy. Now, when it comes to exponents, let's look at this example. We got 3 to the 4th equals x. You sit there and go, I don't need radicals for that, and you're right. 3 to the 4th equals x means we can take 3 times 3 times 3 times 3, and that would equal our x. If we do our multiplication, 3 times 3 is 9, times 3 is 27, times 3 is 81. So we know 3 to the 4th equals 81. No radicals required, you were able to solve it no problem. However, what happens when the variable is put for the base? Here, we need to know that x times x times x equals 343. Now, you may be able to do some guess and check here to try and figure out what number is going to work. But there may be some other cases, such as this one, where we got y to the 7th equals 3,187, that doing a guess and check to try and figure out what number is going to work is going to be a pain. So let's go back to that 3 to the 4th equals 81. This is written in what is known as exponential form. 3 is the base, the 4 is the exponent, and we got 81 for the answer. In radical form, we're still going to use all those numbers. Notice the 3 is still here, the 4 is now here, and the 81 is over there. As far as what the pieces and parts mean, the symbol is referred to as the radical symbol. What was once the exponent is now the index, and what was the answer is now referred to as the radicand. We're now going to take a look at some examples on how to go from exponential form to radical form. You may want to pause and do these on your own, or you can just follow along. So, to do this, let's start with the radical symbol. The exponent will become our index. What was the answer will become the radicand, and what was the base will now become the answer. If we look at the next example, once again we start with the radical symbol. The exponent was an 8, that will now be the index. What was the answer becomes the radicand, and what was the base is now our answer. Now, it is important that we take a second and look at square roots. Personally, I do not know if it's because they were developed first or because they're used so often, but mathematical tradition holds that instead of writing the index of 2 with every square root, they tend to leave it blank. Mathematical shortcut, I guess. Which means that if we were writing this one, typically we put our index, or in this case 2 there, we'd put the 25 inside as our radicand, and the base would become the answer. So typically it would look like that. However, more often than not, you're going to see that mathematical phrase written that way, the square root of 25 equals 5, without the 2 for the index. Or for this one, if we were following proper mathematical processes, we'd write it with the 2 for the index. But since it's a square root, you're more likely to see it written like that. The square root of 144 equals 12. Now, if we move on to ones with the variables, you'll see how this is going to start coming into play when we have to solve equations. We would start with our radical symbol. We keep our index. The answer becomes the radicand. And note the x, which was the base, will now become our answer. So we'll be able to solve for x. Or for this one, once again, we start with our radical symbol. We got 2 for the index. The 49 will become our radicand. And the y, which was originally the base, will become the answer. Once again, since this one involved an index of 2, you're more likely to see it written as the square root of 49 equals y without the 2 for the index. Now, it's always good to be able to go in the other direction as well. So here we're going to go from radical form back to exponential form. So what is the answer will be the base. What is the index will become the exponent. And what was the radicand is now the answer. We try another one. The answer will be the base. Note there's no index, which means it's a 2, because it's a square root. And the radicand becomes the answer. And this should hopefully make sense, because 10 times 10 is 100. If we throw in the variables, you'll see how we'll be able to solve equations then. So the answer becomes the base. The index becomes the exponent. And the x, the radicand, will now become the answer. So we'll be able to solve for x. In this case, the 1.3 is our base. No index written again, so that means it was a 2, so we're going to do a square. And that will equal the y. So I hope this video has helped you understand how exponents and radicals are related. In future videos, we will look at how to simplify and do mathematical operations with radicals. I wish you good luck. Goodbye.